Solutions, NCERT chemistry solution, vapor pressure of liquid solution. So vapor pressure, the pressure exerted by the vapor molecule over the surface of the liquid is called vapor pressure. The pure solvent possesses less vapor pressure than that of solution. For example, now we are having the pure solvent, we are measuring the vapor pressure of the pure solvent. Now we are adding solute to the solvent to make it into a solution. Now we are measuring the vapor pressure of the solution. The vapor pressure of the solution is less than that of pure solvent because of the added solute molecule, because of the number of ions of solute, because of the mole fraction of the solute added. The added solute molecule attracts the solvent molecule. There is an attractive force between the dissolved solute and the solvent. The attractive force which binds the solvent molecule, thereby to prevent the solvent molecule to come out of the surface. Thereby in the case of the solution, the vapor pressure decreased. Now we are going to see the topic vapor pressure of the liquid solution. The liquid solution means the solvent is liquid that is easily evaporatable. The solute may be of gas, liquid or solid. In this case, we are going to see evaporatable solid, volatile solvent medium, the solution of the type liquids in liquids and solids in liquid. Now consider a binary solution containing two volatile liquid. The total vapor pressure can be calculated by the P1, P2 and the vapor pressure of the two components 1 and 2. That is mole fraction is X1 and X2. The French chemist Raoults gave the quantitative relationship between the vapor pressure and the vapor pressure and of the volatile liquid and the mole fraction. That is, the partial vapor pressure of each component of a solution is directly calculated from the partial vapor pressure. The partial vapor pressure of each component present in the solution is calculated from the mole fraction. Now consider the partial pressure of the first component P1 that is proportional to X1. The partial pressure is calculated by, the partial pressure of the P1 can be calculated by the partial pressure of the pure component in its mole fraction. Similarly, for the component 2, the partial pressure can be calculated by the partial pressure of the pure component and its mole fraction. The product of partial pressure of the pure component and its mole fraction. So, according to the Dalton law of partial pressure, the total pressure is calculated by the sum of the partial pressure of the component present in the solution. So the total pressure is the partial pressure of the pure component P1 and the mole fraction of X1, partial pressure of the pure component P2 and X2. So X1 P1 and X2 P2. The X1 is actually X1 plus X2 is equal to 1. So X1 is equal to 1 minus X2. So in this place, instead of X1 we can substitute 1 minus X2. So 1 minus X2 into P1 plus X2 P2. Here the X2 is common, thereby we can take that out by writing P1 not the pure component, P2 minus P1 not is equal to X2. That equation can be written like that. So the partial pressure of the solution is the component present in the mixture is the product of multiplication of the partial pressure of the pure component and added solute. So the partial pressure is directly proportional to the mole fraction or number of solute or concentration of the solute present in the mixture. So now we are drawing the diagram or the graph relating the partial pressure of the two components P1 and P2. Here that is varies directly. The partial pressure varies directly linearly with the mole fraction. The partial pressure of the P2 linearly varies with the mole fraction. The lowest minimum value is P1 partial pressure, the maximum value is P2, the total pressure of the liquid solution is partial pressure of P1 and P2. So from the above theories we can conclusion that total pressure over the solution can be related to the mole fraction of the any component present in the mixture. Total vapor pressure varies linearly with the mole fraction of the component 2, it is the maximum value. And vapor pressure of the pure component 1 and 2, the vapor pressure over the solution increases with the mole fraction of the component 1 and 2. The composition of here the vapor pressure P2 is greater than P1, but it varies with the mole fraction. The composition of vapor phase in equilibrium with the solution determined by the partial pressure of the components. Now for example, Y1 and Y2 are the mole fractions of the components 1 and 2 respectively, the vapor phase using Dalton's law of partial pressure. The partial pressure of P1 is equal to mole fraction in total pressure. Partial pressure of 2 is equal to Y2 into partial pressure, total pressure. That is, in general, the partial pressure of the I component is equal to mole fraction of the I component into the total partial pressure. So from that, the Rowlett's law, what is Rowlett's law is the partial pressure of the partial pressure of the solution directly proportional to the mole fraction present in the solution. The sum of the partial pressure is equal to the total partial pressure is equal to sum of the partial pressure present in the compound. So the partial pressure depends upon the mole fraction, that is concentration or number of ions. Subscribe for more videos. Thank you.